The first thing that breaks the stillness is not sound, but light. 6 brief flashes on the dark face of the moon reveal the central truth at once. The lunar surface is not asleep. It is a place under constant impact where even a small stone can arrive with the force of an explosion. Against a blackened disk, each burst appears and vanishes in less than a second. Nothing lingers, no smoke rises, no echo follows. The event is over before language can fully settle around it. That is what gives the moment its weight. A world that often looks frozen from Earth begins to show itself as exposed and restless. In that region, motion never needs wind or weather. Motion comes from objects crossing empty space and ending their journey in a flash of heat. The scale feels distant at first, almost too distant to hold. Then the mind finds a simple comparison. A pebble tossed into a still pond makes a ring that spreads outward. On the moon, a pebble from deep space makes no ring in water. It makes a ring in stone. The shape is different. The silence is absolute. But the principle is strangely familiar. A small object arrives. The surface answers. This is the first unlock of the journey. The moon does not merely preserve the past. It is still being written on. Its face is not a finished page. It is a sheet of pale rock under a slow and endless rain. Under that calm idea sits a physical reality that is harder to picture. The moon has no meaningful atmosphere. There is no thick layer of air to slow incoming debris, no glowing trail to soften the arrival, and no cushion between space and ground. On Earth, tiny fragments burn high above the surface and vanish as streaks of light. On the moon they strike. Even a small fragment can move fast enough to heat itself and the ground around it to a white glow. The flash is brief because the event is brief. Energy appears, reds and fades almost at once. A crater may remain, but the light does not. This is the second unlock. Lunar quiet is not safety. It is exposure. The calm appearance of the surface hides the fact that nothing shields it. A grain, a pebble, or a larger rock all arrive without resistance. The difference is only in scale. The process remains the same. A hard surface receives what space delivers. At this distance, intuition begins to fail. Daily experience teaches that danger announces itself through wind noise or movement. On the moon, there may be no sign at all until the impact itself. Observation reaches a limit here. A flash can be seen after the strike, but the object before the strike is usually lost in darkness and speed. The eye sees the ending, not the approach. The scene grows clearer when the darkness itself becomes the visual anchor. Imagine the moon not as a bright disk in a familiar sky, but as a black circle with a thin white edge of light around it. The surface below is barely visible. Then somewhere on that dim face a point ignites. It is as small as a pinhead at arm's length, yet that tiny point marks a collision powerful enough to throw material outward and carve fresh damage into ancient ground. The geometry matters. A flash on a curved surface is not flat. It blooms against ridges, slopes, and crater walls, even if the eye only catches it for an instant. A slight rise near the impact may catch the light differently from the lower ground around it. That is why a single burst can feel sharper than its size suggests. Light meets relief. Shape briefly becomes visible. The moon offers one of its oldest habits in miniature. It records violence through form. A crater rim, a bright ejecta patch, a faint scar that lasts longer than any witness. The journey begins here because it compresses the whole lunar story into one event. Countless impacts over immense spans of time have built the surface that now seems so still. One visible flash is like a single snowflake landing on a field already shaped by winters beyond counting. There is also a quiet shift in scale that happens beneath the event. The flash is tiny in the window of a spacecraft. The process behind it belongs to the architecture of a world. Small debris falls in seconds. Cratered terrain accumulates over billions of years. The same mechanism governs both. This is where the mind needs a gentler rhythm. It helps to step from the instant outward. First the point of light, then the fresh crater, then a surface covered in overlapping circles. Then an entire hemisphere marked by impact after impact. What looks like one isolated event is part of an almost continuous pattern. The moon is less like a polished sphere than like weathered plaster, pressed by countless fingertips. Some marks are enormous and easy to name. Others are so small they never enter a map. Together they create the texture that defines the lunar face. The flashes simply let that hidden process announce itself in real time. For a moment, the slow making of the moon becomes visible. That is rare. Most planetary change is too gradual for direct notice. Here, change arrives in a spark. Another limit of intuition appears in the strange balance between beauty and hazard. The flashes are beautiful because they are clean and brief. They resemble distant stars appearing where no stars should be. But beauty can mislead. A visible burst on the moon is not decoration. It is the sign of a surface being struck with tremendous speed. This matters because every future movement near the moon must accept the same condition. A place without air is also a place without mercy for incoming debris. The observation does not need drama to be important. It only needs stillness and accuracy. A bright point on dark rock is enough. The scene already contains the lesson. What seems empty is active. What seems dead is being reshaped. What seems solent is full of impacts, too small, too quick, or too faint to notice one by one. From this first image, the path of the story opens naturally. A few flashes on a dark world lead into a larger question about what the moon really is when seen up close. The next movement does not leave that silence behind. It goes deeper into it toward the long blackout where distance becomes more than a number, and the far side begins to change everything into a different kind of view. The next threshold is not marked by flame or motion. It is marked by disappearance. As the path curves behind the moon, Earth slips below the lunar horizon and every direct link to home falls away. This section rests on one simple fact. The far side is not only hidden from Earth, it also hides Earth from anything that passes behind it. The result is a silence that feels physical, as if a great wall of stone has moved between one world and another. No signal passes through that mass, no shortcut crosses it. The geometry is plain and absolute. Rock blocks are radio. Distance becomes more than mileage. It becomes separation with shape and weight. The visual anchor here is gentle and severe at once. A blue sphere lowers behind a grey rim until only darkness and rock remain. It resembles the last light of a harbour slipping behind a headland, but the scale is far beyond any coast. A horizon on Earth hides a few miles. This horizon hides an entire planet. The early unlock arrives quietly. Isolation in deep space is not only emotional, it is built into the path itself. Once the far side intervenes, communication does not weaken gradually. It ends. This matters because the moon is often imagined as nearby, almost familiar, because it hangs so steadily in the sky. Yet closeness in appearance is not the same as access. A nearby lantern behind a thick door is harder to reach than a distant one across an open field. The moon creates that door. Its bulk is the barrier. This is the first payoff of the blackout. A single curve of terrain turns a visible destination into a sealed region. In that region, waiting replaces conversation. Timing replaces reassurance. A return depends not on constant contact, but on motion already set in place. The mind tries to compare the moment to a tunnel, a cave, or a valley, without signal. Those analogies help for a breath, then fail. Tunnel has walls that can be touched. A cave belongs to a world with air. The far side belongs to open space where the emptiness around the craft does nothing to soften the fact that one solid body has removed all direct connection. Physical detail makes the silence more real. The moon is tidally locked, so one hemisphere faces Earth while the other remains turned away. That simple arrangement creates a front and a hidden back not by mystery, but by rotation matched to orbit. Once the path bends around, the hidden half-line of sight disappears. The phrase sounds abstract until it is turned into an image. Draw a straight thread from one side to another, then place a stone in the middle. The thread no longer reaches. That is all line of sight is at its core, straight access interrupted by mass. This is the second payoff. The blackout is not a failure of machinery, it is the expected consequence of shape. That makes it calmer but not smaller. At this distance there is no way to speak through a world. The silence is as old as the moon itself. Every orbit behind that edge repeats the same rule. Observation reaches another limit here. Even with perfect knowledge of the path, direct confirmation is gone for a time. Thought continues, systems continue, but proof must wait until reappearance. The visual rhythm of the far side deepens the effect. Light thins across crater rims and long ridges. Valleys drop into shadow. The surface does not look smooth from this angle. It looks broken into shelves, bowls, and scarred rings. Beneath that terrain, Earth is absent from view. The absence matters as much as any visible object. A blank window can alter scale more sharply than a crowded one. When home is visible, distance is measured against something known. When home is hidden, distance becomes abstract and larger. The comparison that fits best is not an ocean crossing, but the moment a mountain road turns and the valley vanishes. The road remains under the wheels, the map still holds. Yet the loss of sight changes the whole body. On the far side, that shift happens on a planetary stage. The moon fills the frame. Earth is gone. The craft continues, but perspective narrows to rock shadow and the certainty that return is still ahead, though not yet visible. A gentle scale shift begins to work here. First there is the single window and the missing planet. Then there is the larger pattern of every lunar orbit that has ever passed behind the far side. Seconds turn into minutes. Minutes join a long history of repeated blackouts. What feels singular is also structural. Any path that swings behind the moon inherits the same interval of separation. This is why the blackout matters beyond one journey. It is not an exception, it is part of the landscape. Future flights, orbital stations, and surface operations near the hidden hemisphere all meet the same condition unless another layer of relay or infrastructure changes the geometry of communication. The moon does not merely offer a place to travel, it imposes rules on how that travel unfolds. Some of those rules are visible in craters and dust. Others are visible only when contact ends. Silence becomes one of the moon's terrain features, even though it is made of line angle and blocked signal rather than stone. Another small payoff arrives in the return itself. Reappearance is not dramatic in the way fiction often imagines. It's a gradual restoration of link and sight. The curve is completed, Earth lifts back above the rim, contact returns because the straight path is open again. This is why the first glimpse of Earth after the far side carries more weight than the first loss of it. The loss is geometric. The return feels almost biological, as if something essential has come back into view. Yet nothing in the cosmos has changed during those minutes. The moon remains the moon. Earth remains where it was. Only the position of the observer has shifted. This is a useful correction to intuition. Enormous emotional change can come from a very small change in angle. A few degrees of motion around a spherical body are enough to divide solitude from connection. The cosmos often works that way. Vast feeling, simple cause. By the end of the blackout, one truth has settled into place. The far side is not only a region of unusual terrain, it is also a region that changes the meaning of distance by removing sight and speech together. That prepares the way for the next section, where the hidden hemisphere stops being only a place of silence and begins to show its own face, its own texture, and its own deep difference from the moon long known from Earth. The far side does not feel like the hidden half of a familiar object. It feels like a different moon. That is the early anchor of this section. The difference is not a trick of angle alone. It comes from crust heat lava and a long imbalance written deep inside the body of the moon. The visual change appears first as absence. The broad dark plains that shape the near side are mostly gone. In their place lies a pale terrain crowded with craters, ridges, broken rims, and overlapping scars. The face long known from Earth has large, smooth patches that calm the eye. The far side offers very little of that relief. It looks older not because it truly begins earlier, but because fewer later flows have softened its surface. The scene resembles a wall that has never been replastered. Every crack, dent, and impact mark remains visible because so little has covered what came before. This is the first payoff. The moon has two visibly different hemispheres because the crust is not the same thickness everywhere. On the far side, the crust is thicker. That extra rock matters because it limits how easily molten material can rise from below. When large impacts open basins, the near side more often allows lava to flood upward and spread across the surface. On the far side, that pathway is harder to open fully. The result is simple to say, even if the interior story is complex. One hemisphere develops many dark volcanic plains, the other keeps more of its battered highlands exposed. A new term helps here briefly. Maria are dark volcanic plains on the moon. After that definition, the rest can return to plain language. On the near side, these plains gather into broad dark patches. On the far side, they are scarce. The reason matters because it links surface appearance to hidden structure. A visible colour difference begins as a difference in depth. Physical detail sharpens the contrast. The far side is dominated by highlands. Highlands are lighter in tone and more densely cratered. Their rims pile over one another. Their floors sink into shadow. Some basins are so ancient that later impacts have softened their edges into broad damaged rings. The surface has layering in both shape and time. A younger crater may sit inside an older one. A sharp rim may cut across a gentler depression. Light slides over these forms and reveals how little smooth ground exists between them. This is where the visual anchor settles. A low sun touches the crests first. The valleys remain dark. Pale ridges appear like dry surf frozen in stone. The comparison is not to ocean water in motion, but to the wrinkled skin left behind after water has long vanished. The moon keeps the form without the flow. At this scale, even a single basin can stretch so wide that the eye loses the sense of standing above one feature, and instead feels suspended over a field of nested circles. The next payoff comes from temperature, though not the kind felt directly. The near side and far side do not only look different, their thermal histories part ways. A region on the near side contains more heat-producing elements, including materials that help keep the interior warmer over long spans of time. That warmth encourages volcanic activity. More warmth means more opportunities for molten rock to rise and spread. Less warmth means a quieter interior and fewer resurfacing floods. The far side becomes the colder record. The near side becomes the more altered one. A useful, everyday analogy is a loaf baking unevenly in an oven. One side remains warmer longer and stays soft enough to change shape. The other side firms up sooner and preserves more of its earlier texture. The moon is not bread, of course, and the timescale is beyond ordinary thought. But the pattern helps. One side stays more active. One side settles into a harder stillness. That difference shapes the face seen today. A gentle limit of observation enters here. Surface color alone cannot reveal the full interior story. Cameras, maps, and reflected light show patterns, but they do not directly expose the heat history buried below. Inference does much of the work. Thickness is measured indirectly. Interior warmth is reconstructed from deformation chemistry and returned material. This is the limit. The eye can confirm that the two halves look unlike one another. The deeper cause must be assembled from many traces rather than watched directly. Planetary science often moves this way. A visible clue sits on the surface. The explanation lies far beneath it. The moon appears to offer one simple object in the sky. In practice, it behaves more like layered stone cut open only in fragments. Some layers reach the surface through impacts. Others remain known through the way mass heat and rock respond over time. Another scale shift helps the picture settle. At first, the contrast is just two colours in a familiar disk. Then it becomes two kinds of crust, then two thermal histories, then a divergence that stretches back toward the moon's earliest formation. What appears now as pale highland and dark plain was seeded when the interior was still young. A difference buried deep became a difference visible from afar. This is why the far side feels so strange. It is not merely farther from Earth-facing attention. It preserves another branch of lunar history. The near side tells the story of flooding and resurfacing. The far side tells the story of endurance and retention. One face was revised more often. The other kept more of its old damage in view. A sphere that seems simple from Earth turns out to contain a split memory. The section can close on the image that best holds the contrast. One half of the moon carries dark pools of ancient lava. The other half carries pale highlands crowded with scars. The difference is not decorative, it is structural. That quiet realization prepares the next movement of the journey. Once the far side is understood as a different geological world, the return of Earth above the lunar rim no longer feels like a simple reappearance. It becomes a shift from one face of reality to another, and from stone back to home. Earth does not return as a concept. It returns as a sight. After the far side has removed it completely, the first glimpse above the lunar horizon carries the whole meaning of distance in a single image. That is the early anchor here. Nothing about Earth has changed during the blackout. The change happens entirely in angle, yet the effect feels much larger than geometry should allow. A blue and white sphere rises above greystone, small enough to be framed by a window, and powerful enough to reorder every scale at once. The visual anchor is simple and steady. A curved lunar rim lies in shadow. Above it hangs a bright world with cloud bands and ocean light. It resembles a lantern lifting over a dark hill at dusk, except the hill is a moon, and the lantern contains every known sea storm forest and shoreline. That is the first payoff. Home can appear tiny without becoming less central. In fact, the shrinking of Earth in the frame is exactly what reveals its weight. The physical detail that gives the moment shape is contrast. The moon below is dry grey, cratered and nearly without air. Earth above is bright layered and wrapped in cloud. One body shows scars, the other shows weather. One preserves impact marks for immense spans. The other constantly erases and redraws its own surface through water, wind and motion. The eye catches this difference instantly. Grey looks fixed. Blue and white look alive with movement. A thin atmosphere invisible from the ground becomes one of the most striking parts of the planet from far away. It appears as a faint luminous edge around the disk, delicate and narrow. This is the second payoff. The part of Earth that sustains life is visually slight. It is not a vast shell, it is a thin boundary. A useful analogy is frost on glass at first light. From inside a room it may seem ordinary. Seen from outside, it is revealed as a fine layer, beautiful and fragile because it is so narrow. Earth's air has that same kind of visual humility from lunar distance. It is present essential and remarkably thin. The moment also corrects a common intuition. From the ground, the moon seems large because it dominates a dark sky. From near the moon, Earth can seem both smaller than memory and more important than ever. This is where scale shifts gently again. A planet that holds mountains, oceans and continents appears as a compact sphere. The eye can cover it with a thumb at arm's length, yet the fact that it fits so easily inside a simple frame does not reduce it. It concentrates it. All landscapes become one globe. All weather becomes one moving skin. All division disappears into colour and curvature. The section does not need grand language to make the point. A world becomes easier to understand when its borders stop announcing themselves. At this distance, coastlines remain. Country lines do not. This is not philosophy added on top of the image. It is a direct consequence of what remains visible and what does not. The visible planet is continuous. The invisible arguments belong to scale too small to survive the view. Another payoff appears through repetition. Earthrise is often imagined as a single historic image, but the deeper value is that it can happen again and still feel new. The curve of the moon, the black behind it, and the lit planet above it create a composition that is physically simple and emotionally difficult to exhaust. The reason lies in motion. Earth does not leap into view. It emerges slowly as the observer's path changes. That gradual appearance allows the mind to track the transformation in real time. First a sliver, then a bright arc, then a full disk rising free of the horizon. This is like watching an island appear through morning haze from the deck of a ship, except the ship is following a path through vacuum, and the island is an entire planet. The analogy helps because both scenes depend on emergence rather than surprise. Form is revealed in stages. Each stage gives the eye time to accept what it is seeing. That time matters. Slow revelation settles more deeply than a sudden cut. A limit of observation quietly enters here as well. No image, no matter how sharp, can carry the physical sensation of seeing Earth against the surrounding black with nothing else competing for attention. Photographs preserve arrangement and colour, but they flatten scale and remove the body's own sense of position. The view from near the moon includes not only the sight of Earth, but the awareness of where that sight is occurring. That is the limit. A recorded frame can show the scene. It cannot fully transfer the condition of being there with one world under the observer and another hanging beyond it. This matters because Earthrise is often discussed as though it were only a picture. It is more accurately a relationship among objects in motion. The observer, the moon and Earth all take part. Change the path and the feeling changes. Change the altitude and the framing changes. Change the light and the emotional balance of grey and blue changes with it. The physical structure of the scene deserves one more slow look. The lunar horizon is not smooth. It is cut by crater rims, low rises and uneven edges. Earth above that rugged line feels even more round and whole because the foreground is broken. The mind reads the moon as old stone and Earth as contained brightness. White cloud systems curl over blue water. Brown or green land may appear through openings in the clouds. The atmosphere softens the edge just enough to separate it from the hard line of the moon below. Two planetary stories occupy one frame. One is a record of impact and preservation. The other is a record of circulation and renewal. This is the larger unlock of the section. Earthrise is not only beautiful because home returns to view, it is beautiful because it places two kinds of world side by side and lets their differences speak without any need for argument. By the close of this moment, the journey has moved from silence into perspective. The far side has shown the moon as strange and heavily scarred. Earthrise answers not by reducing that strangeness, but by giving it context. The next section can now narrow its attention again away from the emotional sweep of the returning planet, and toward the subtler work of perception itself, where changing light and trained observation begin to reveal what fixed images often leave behind. The moon does not reveal itself all at once, it changes with light and light changes with motion. That is the early anchor of this section. A fixed image can preserve detail, but a moving eye under shifting illumination can uncover relationships that a single frame leaves flat. The value of direct observation begins there. It is not magic. It is the simple advantage of watching one landscape pass through many angles of brightness in continuous time. The visual anchor is a basin wall slowly changing as the sun slides across it. First the rim is pale and clear, then a shadow lengthens down one side, then a faint colour difference appears as where the circular slope steepens. It resembles a tray of fine dust near a window at sunset. Move the tray slightly and low ridges appear that were invisible before. Nothing in the dust has changed. Only the angle of light has shifted. The moon works the same way though, on a scale so much larger that the comparison feels almost too gentle. Yet that gentleness helps. The first payoff is simple. Light does not only illuminate a surface, it chooses which features become legible. This is why trained observation matters so much in a flyby. The human eye sees a continuous range of tones and adapts quickly to changing brightness. That does not make it superior in every way to instruments. It makes it responsive in a different way. A camera may gather exact information in chosen bands of light. An eye connected to a practiced mind can notice when one crater floor looks slightly browner than the slope beside it, or when a ridge becomes visible only at one low angle and then vanishes again. The difference can be subtle. A slight greenish cast in a pale highland, a darker patch that does not match the surrounding ejecta, a sharper rim that signals fresher material. This is the second payoff. Observation is not only about seeing more, it is about seeing change in relation to change. A surface is interpreted through sequence, not just through clarity. That is why motion across the moon matters even when the ground below remains still. Physical detail sharpens the point. Lunar terrain is full of relief. Basin rings step outward in broad arcs. Crater rims rise and break. Valleys collect shadow long before nearby peaks do. A low sun stretches darkness across the ground and turns tiny differences in height into long visible traces. At high illumination, some of these same features flatten into near invisibility. The shape is still there, but the cue is gone. This is the part daily intuition can miss. On Earth, landscapes are usually seen through air haze, weather and vegetation. The moon strips most of that away. There are no forests to soften a ridge and no clouds to dim a crater wall. What remains is raw topography and reflected light. The analogy here is a sheet of crumpled paper laid under a lamp. Shine the lamp straight down and the paper seems almost smooth. Move the lamp lower and every crease leaps forward. The paper has not changed. The pattern has only become readable. Lunar observation works through that same quiet trick of angle. A gentle limit of observation enters here as well. Even with shifting light, the eye can only infer so much from colour and shadow. A brown tone may suggest a difference in mineral content, but colour alone does not prove composition. A bright patch may indicate fresh ejecta, but brightness can also change with viewing angle. This is where seeing reaches its boundary. Direct perception opens questions more quickly than it closes them. It can identify contrast, texture, alignment, and timing. It cannot by itself provide a full chemical map. In that sense, the eye is a guide rather than a final judge. It says where attention should rest. It marks the places where the surface refuses to stay uniform. This matters because the moon often appears uniform from afar. Grey seems to dominate everything. In closer observation, grey separates into many kinds of grey, and then into muted browns, pale whites, faint blue tones, and subtle transitions that are easy to miss if light is treated as static. Another small payoff appears through the rhythm of looking itself. Observation is tiring when brightness changes quickly. Eyes must adapt between dark cabin interior and bright exterior view, or between shadowed terrain and sunlit rim. That adaptation is physical, not merely mental. Pupils shift, contrast sensitivity changes, the act of seeing becomes work. This detail matters because it reminds the story that perception is embodied. Information does not simply arrive untouched. It passes through a visual system with limits, delays, and moments of heightened sensitivity. That bodily fact is part of the science. A landscape under changing light is not only an object to inspect, it is also an experience that unfolds in pulses of clarity. A ridge appears, a patch of tone separates from the ground around it. Then the angle changes and the feature softens again. Observation becomes a tide of appearance and loss. That is why continuous looking can matter more than a single perfect glance. The scale shift in this section is especially calm. It begins with a tiny shade difference on one wall of a crater. Then it widens to an entire basin ring. Then to the understanding that whole geological histories can hide inside changes of light, so slight that they disappear in a still image. Seconds of changing illumination can reveal features shaped over billions of years. The short and the immense touch each other here. A passing angle of sunlight uncovers a process frozen since deep time. That contact between brief seeing and ancient formation gives the lunar surface a strange stillness. Nothing moves on the ground, yet the meaning of the ground keeps changing as light moves across it. It is like reading raised letters with a fingertip. The letters were always there, but meaning arrives only when contact passes over the right contours. By the end of this section, one truth has settled. The moon is not only a place of craters and plains, it is also a place where perception itself becomes part of the inquiry. Shifting light turns the surface from a static image into a sequence of revelations. That prepares the next movement where observation passes from geology into memory, and one small feature on the moon begins to carry the weight of a human name. A landscape becomes different once a name settles onto it. That is the early anchor here. A small crater on the moon is still a crater in physical terms, with a rim, a floor, a spray of brighter material, and a place inside the larger geometry of the surface. Yet once memory attaches itself to that shape, the terrain begins to hold more than geology. The visual anchor is modest and clear. A bright mark sits on the grey ground near older damaged terrain. It does not dominate the hemisphere. It does not alter the orbit of anything around it. It simply catches light more sharply than the darker surface nearby. That brightness is the first clue to why such a feature can stand out at all. Fresh material on the moon often appears lighter because it has had less time to darken under space weathering. A young scar remains pale before long exposure slowly dulls it. This is the first payoff. A crater can become visible for two reasons at once. It can be geologically young and it can become emotionally legible. The physical detail matters because memory needs a place to rest on. A fresh crater usually has a crisp edge, its ejecta spread outward in a faint fan or patch. The contrast between its pale surface and the surrounding ground can make it look almost like a dropped bead of chalk on old slate. That comparison is gentle, but it helps. The moon is covered with marks, yet not all marks carry the same visual force. Some have softened into the general tone of the surface after immense spans of exposure. Others remain bright enough to announce themselves from far above. This is the second payoff. The moon keeps recent damage visible longer than Earth would. On Earth, rainwind, vegetation and erosion begin the work of concealment almost at once. On the moon, concealment is slower and quieter. A bright crater may remain distinct for a very long time before the surface around it fully reclaims it in tone. That persistence gives memory a stable anchor. A name place on the moon has a chance to last not for a season, but for epochs. There is a deeper reason this matters beyond sentiment. Naming changes how a landscape is mentally organized. Before a feature has a name, it belongs mostly to pattern, coordinate, and shape. After naming it, begins to gather attention differently. The eye returns to it. The mind recalls it more easily. A region that had been one part of a broader field becomes a point of return. In that sense, naming is a kind of mapping that happens inside memory rather than on paper. The analogy here is a path through a forest before and after one tree is marked. The forest remains the same. The route does not physically change. Yet a single known tree can reorient the whole walk. A crater given a name works in much the same way. It turns surrounding terrain into context. This is the quiet unlock of the section. A place becomes more than its dimensions once it begins to hold reference, grief, continuity, or affection. On the Moon, where so much terrain is ancient and impersonal that shift can feel especially strong, a limit of observation also enters here. From a distance, a crater can be described by brightness, diameter, rim sharpness, and position relative to nearby basins or ridges. None of those measurements can reveal why a certain name matters. Observation reaches stone and reflected light. Meaning lies elsewhere. That boundary is worth stating softly because the lunar surface often invites the illusion that everything important can be reduced to morphology. But a name introduces another layer that cannot be measured in rock alone. The crater remains physically identical whether named or unnamed. Its slope angles do not change, its ejecta does not spread farther. The added significance is not visible in the terrain itself, it exists in the relationship between a remembered life and a permanent landmark. Planetary science and memory meet here without replacing one another. One describes the feature, the other gives it human weight. Even at lunar distance, those two forms of meaning can coexist without cancelling each other. The visual rhythm of the section returns to the crater itself. Imagine a pale spot emerging near the boundary of older terrain, its rim catching low sunlight while the surrounding plane stays muted. Small shadows gather along one side of the lip. A thin brightness extends outward, where material once landed after the impact. The form is not grand in the way a giant basin is grand. It is intimate by lunar standards. That scale matters. Not every meaningful feature needs to be immense. Sometimes a smaller mark is more suitable because it can be held in the mind as a single whole. The scale shift here is gentle. A crater perhaps modest within the geography of the Moon becomes immense when measured against a family history or a single remembered life. What is minor on a planetary map can become central in another register entirely. The Moon allows that compression. Its surface is large enough to dwarf the individual features and stable enough to preserve them once attention settles. Another payoff appears through the contrast between change and endurance. The life attached to the name belongs to time measured in years. The crater belongs to time measured in millions. Yet the connection does not feel strained, it feels clarifying. A short human span placed beside an ancient surface can sharpen rather than diminish both. The remembered life gains a kind of permanence through association with the landscape. The landscape gains tenderness through association with the remembered life. This is why such moments echo so deeply even in a story dominated by geology and distance. The Moon is often treated as the opposite of human scale. It is cold, dry, exposed and far. Yet exactly because of that remoteness, any act of memory placed there appears with unusual clarity. A name against such a backdrop is like a small warm note pinned to a vast stone wall. The wall remains severe. The note does not soften the stone, it simply changes how the eye approaches it. By the close of this section, the Moon has taken on another layer. It is still a record of impacts, crustal differences and changing light, but it is also capable of holding memory in a way that feels strangely appropriate to its permanence. That prepares the next movement naturally. After one bright crater becomes a point of remembrance, attention can return to the broader surface again where light along the dividing edge between day and night begins to reveal the Moon in its most rugged and unexpected form. The Moon becomes most rugged when light nearly leaves it. That is the early anchor of this section. Along the line between day and night, low sunlight stretches every rise into a long shadow and turns gentle relief into sharp relief. Features that seem flat under overhead light suddenly stand apart. The visual anchor is a broken field of ridges and crater rims near the terminator. Some peaks still catch sunlight. The ground around them has already dropped into blackness. They look like bright fragments suspended above a dark floor, not because they float, but because shadow has removed everything lower from view. This is the first payoff. The terminator does not create new terrain. It reveals the terrain that bright light had hidden by flattening it. A brief definition helps here. The terminator is the boundary between lunar day and night. After that, the section can return to plain language. On the Moon, sunlight reaching the surface from a very low angle acts almost like a side lamp crossing textured stone. Tiny slopes become visible because they cast long shadows. Crater rims lengthen. Small ridges darken one side and brighten the other. Valleys vanish first. Higher crests hold light longer. The physical detail is what gives the scene its strange beauty. Light does not fall evenly, it grazes. That grazing makes shape readable. A simple analogy brings it closer. Imagine a woven cloth laid nearly flat. Under direct light, it seems smooth. Under low evening light, the raised threads begin to stand out one by one. The moon at the terminator works in the same way, but the threads are mountain rims and crater walls. This is the second payoff. A change in angle can make a known surface look almost alien without changing a single grain of dust. The reason the view matters goes beyond beauty. Long shadows expose topography with unusual clarity. A subtle fracture, a low dome, or a partially collapsed rim may become obvious only when one side falls dark. At higher sun angles, the same feature can disappear into a nearly uniform tone. This is why the terminator is such a revealing region. It strips away the illusion of smoothness. The far side especially benefits from this treatment because it is so heavily cratered and broken. Under low light, the eye begins to understand that the surface is not merely covered with impacts. It is shaped by them at every scale. Some depressions are vast enough to contain later craters inside them. Some smaller bowls interrupt older slopes. Some ridges are not mountain chains in the earthly sense at all, but the raised edges of ancient collisions. A slow scale shift begins here. First, the eye notices one rim catching light, then a field of rims. Then, an entire hemisphere whose texture has been built through repetition over immense spans of time. The short movement of shadow across the ground reveals a history written over billions of years. Another payoff arrives through contrast alone. At the terminator, bright and dark are placed so near each other that the eye reads them almost as different materials. One peak can glow pale, while the next hollow is nearly invisible. The mind may even mistake some surfaces for new substances because the lighting is so dramatic. A ridge may look white as frost. A basin may seem bottomless. This is where intuition begins to strain. On Earth, atmosphere softens extremes. Haze fills distance. Scattered light lifts shadows and rounds out edges. On the moon, there is no ebb to do that work. Black stays black. Sunlit surfaces remain hard and brilliant. Observation reaches a limit here because relief becomes easy to see, but depth can still be difficult to judge. A shadow marks shape clearly without always showing how far the surface drops. The eye gains one kind of knowledge and loses another. It can map contrast very well, it can still be misled about scale. The visual rhythm deepens when isolated peaks appear as islands of light. This is not metaphor alone. As the terminator advances higher, terrain remains illuminated while lower ground has already entered darkness. The effect can make separate summits look as though they float in a black sea. The comparison fits because the dark around them erases all connecting slopes. The land is still continuous, but sight no longer confirms that continuity. This creates one of the most memorable lunar scenes. A scattered chain of bright points hangs above shadow terrain as if the surface has broken into pieces. The third payoff comes from understanding what is really happening. The moon is not fragmenting. Light is sorting the landscape by height. That quiet sorting turns geology into something almost architectural. Every edge and lip declares itself in sequence. Height becomes visible by endurance. The last surfaces to hold light are simply the highest. A physical detail worth pausing on is the crater rim itself. A fresh rim may be sharper and more abrupt. An older one may be softened by later impacts, its line less crisp, its shadow broader. Along the terminator, that age difference becomes easier to feel. Not by reading dates, but by sensing how tightly or loosely the forms hold together. The moon begins to resemble carved stone worn by time, except the wearing is not done by water or wind. It comes from later impacts, solar exposure, and long stillness. This is another useful correction. Erosion on the moon is real, but it is not the erosion of rivers. It is the erosion of bombardment and exposure. The terminator reveals that special kind of aging through form rather than through motion. By the end of this section, the moon has become sharper and less familiar. The line between day and night exposes its broken anatomy with a clarity bright daylight often hides. That prepares the next movement naturally. Once the surface is seen as a place constantly reshaped by the impacts and relief, the question that follows is no longer only how it looks, but what keeps striking it so steadily, and what that means for any future presence there. The moon is not dangerous because it is dramatic. It is dangerous because nothing slows what approaches it. That is the early anchor of this section. Without a thick atmosphere, the lunar surface receives incoming debris almost directly. A fragment that would burn high above Earth can reach the moon intact and strike at full speed. The visual anchor is quiet and severe. A dark plane sits motionless for ages, Then a tiny impact briefly blooms into light and leaves a fresh scar in the dust. Nothing in the surrounding landscape seems to anticipate the strike. That is the first payoff. On the Moon, hazard often arrives without warning because the usual signs that Earth teaches the eye to expect are missing. A brief definition helps here. A meteoroid is a small rock moving through space. After that, plain language can carry the rest. These rocks come in many sizes, from fine grains to larger fragments. Most are small, but speed changes what small means. A pebble on a path can be ignored. A pebble crossing open space at extreme velocity becomes a high-energy impactor. That is the second payoff. Size alone does not determine risk, speed does. A useful analogy makes the point gently. A fingertip can pass through water without consequence. The same fingertip striking a still pond at great speed sends a hard splash outward. The Moon receives impacts in that second way. Motion turns the modest mass into serious force. This is why even a small object can excavate a crater, brighten a patch of ejecta, and throw material outward across the surface. The physical detail begins with the lack of air. Earth lives under a deep envelope of gas. That envelope heats and slows much incoming debris. The Moon has only a very thin exosphere, far too sparse to act as a shield. As a result, impact on the Moon is often direct conversion. Motion becomes heat. Rock breaks rock. Dust lifts and settles. A small crater forms. A fresh rim appears. Sometimes a bright splash of newly exposed material contrasts with the darker weathered ground around it. The surface keeps these records because very little erases them quickly. This is the third payoff. A world with no atmospheric shield also becomes a better archive of bombardment. The same condition that makes the Moon hazardous also makes it legible. Every strike writes itself into the terrain more clearly than it would on a wetter, softer, more active planet. The sources of this debris are not mysterious in principle, though they are vast in number. Some fragments belong to a general background of material left behind by collisions among asteroids and the decay of comets. Others arrive in denser streams associated with meteor showers, when Earth and the Moon pass through trails of debris left along an orbit. The Moon does not need to invite this material. It only needs to keep moving through space. This is where scale shifts gently outward. One visible sash on the lunar surface leads to the idea of many impacts across an entire hemisphere. Then farther still to a constant sweep of debris through the inner solar system. The Moon is not singled out by malice or rarity, it is simply exposed. Like a roof without tiles in a long season of falling grit, it receives what passes through its path and preserves the result in dust and stone. A limit of observation enters here in a precise way. Large enough impacts can produce visible flashes or obvious new scars. Smaller impacts may leave only tiny marks or none that can be seen from a distance. The Moon is struck by many objects too small to notice individually. This is the limit. Visibility is not the same as frequency. The eye sees the dramatic minority. The surface records the quieter majority. That matters because intuition may overvalue the visible event and undervalue the countless small ones. Yet over long spans, the small impacts matter enormously. They chip-stir, darken, and rework the upper layer of the Moon. The surface dust, called regolith, is in large part the product of this endless grinding. A cratered world is not shaped only by rare giant collisions. It is also shaped by repeated fine damage, almost like stone slowly becoming powder beneath unending taps. Another payoff appears when hazard is translated into planning rather than fear. Any future long stay on the Moon must account for this continuing influx of debris. A structure, a habitat, or even exposed equipment would sit on a surface that remains under bombardment. Most impacts would still be small, but small is relative and a repeated exposure adds risk over time. The analogy here is a window facing years of wind-driven sand. No single grain seems decisive yet. Over long duration, the glass changes. On the Moon, the consequence can be sharper because the speeds are so high and the shielding environment is so poor. This does not make long-term presence impossible. It simply means that protection placement and duration must be shaped by the reality of impact, rather than by the calmer appearance of the landscape. The visual anchor returns one more time to the aftermath rather than the strike itself. Imagine a pale patch of fresh material around a tiny crater brighter than the mature dust nearby. Its edge may be irregular. Its rim may cast a small shadow under low light. Nothing about it needs to be large to be meaningful. It is one new mark among countless old ones, proof that the process continues. The moon's surface is often spoken of as ancient, and that is true, but ancient does not mean finished. It means the record is long, new entries are still being added. This is the larger unlock of the section. The moon is both archive and target. It preserves the past because it remains open to the present. By the close of this section, impact has shifted from a distant spectacle to a structural fact. The moon is beautiful, but its beauty includes exposure and repetition. That prepares the next movement naturally. Once the surface is understood as a place constantly struck from outside attention, can turn inward to another kind of flash, entirely one that does not appear on the moon at all but inside vision itself when energetic particles pass through darkness. Not every flash near the moon appears on the surface. Some of the strangest light arrives with closed eyes in darkness. That is the early anchor of this section. Beyond the strong protection of Earth's atmosphere and magnetic field, high-energy particles can pass through living tissue and produce brief sensations of light. The visual anchor is delicate and inward. A dark field sits behind the eyelids, then a thin white streak or small point appears for an instant and is gone. Nothing in the surrounding cabin would need to glow. Nothing outside would need to flare. The event belongs to the body as much as to space. This is the first payoff. Deep space can become visible not only through windows, but through the way energetic particles interact with sight itself. A short definition helps here. Cosmic rays are fast-charged particles arriving from space. After that, plain language is enough. These particles come from violent processes spread across the wider universe, then travel enormous distances before crossing a spacecraft, a wall, or an eye. On Earth, most of them are diverted or weakened before they reach the ground. The planet's magnetic field deflects many. The atmosphere absorbs many more. Near the moon, that layered protection is greatly reduced. The result is not constant visible light, but a greater chance that a particle will pass through the head or eye and leave a momentary trace in vision. This is the second payoff. Space does not need to shine to be bright in effect. Invisible radiation can still produce the sensation of light when it deposits energy in the right place. The physical detail is important because the phenomenon can sound unreal when stated too quickly. The eye is not acting like a window here. It is acting like a detector. A charged particle may move through the fluid inside the eye, through the retina, or even through parts of the visual system deeper inside the head. In each case, a brief signal can be created. The brain reads that signal as light, even though no ordinary beam has entered from outside. The shapes vary. Some reports describe points. Others describe short lines or tiny star-like bursts. The variability makes sense because the path of a particle through tissue is not always the same. A different angle can create a different impression. The analogy that helps most is frost sparking on a cold pane when no lamp is aimed at it. The pane does not generate a full scene. It only gives a tiny glint when something touches it in the right way. Vision in deep space behaves in a similarly fragmentary way. A passing particle does not reveal the universe. It creates a momentary sign that the body has been crossed. Another payoff comes from what this phenomenon quietly implies. The flash is not only curious, it is evidence of exposure. A visible streak in darkness means a high-energy particle has moved through living matter. That matters because the same radiation that can trigger a visual event can also damage cells and molecular structures. The flash is therefore both perception and warning. It is gentle in appearance and serious in meaning. A small white mark in darkness may be as brief as a firefly. Its cause belongs to some of the most energetic processes known. This contrast is where intuition begins to fail. Earthly experience links danger to heat, noise, or force that can be felt directly. Radiation often offers none of those signals. Its effects may be delayed, cumulative, or entirely invisible. Here, for once, the invisible becomes faintly perceptible, but only faintly. Observation reaches a limit. A flash does not reveal the full dose, the full risk, or the long-term consequence. It only confirms that the shielding is incomplete. The scale shift in this section is especially wide. It begins inside the eye in a tiny region of tissue where a particle leaves a trace. Then it expands outward to the space around the moon, where protection is thinner. Then farther still to the larger environment of energetic particles moving through the solar system and beyond. A microscopic event becomes the sign of a cosmic journey. That relationship is one of the strangest in space science. Something too small to feel with ordinary touch can point back to events of enormous scale. The body becomes the meeting place between the minute and the immense. A useful everyday comparison is a single raindrop tapping a quiet roof at night and revealing the presence of a whole weather system beyond the house. The drop itself is small. The system behind it is vast. A radiation flash in vision works in much the same way, says Cindy Hill. One tiny event hints at a surrounding environment far larger than the event itself. There is also a softer lesson here about the limits of protection. Earth is not only home, it is shield. Near the surface, daily life rarely needs to think about how much invisible filtering is happening overhead and around it. Air and magnetism perform their work so continuously that they become easy to forget. Near the moon, that protective background becomes more visible by its absence. The body begins to register what Earth normally spares it from noticing. This is the third payoff. Distance from Earth is not only measured in miles or time, it is also measured in how much of Earth's hidden protection has been left behind. A quiet flash in darkness carries that truth more gently than a chart or measurement ever could. The visual anchor returns one last time to the closed field of vision. Dark, then a faint streak, then dark again. Nothing dramatic follows. The stillness resumes. That rhythm is important. Deep space radiation does not usually announce itself as a storm of constant brilliance. It appears in small incidents separated by calm. That spacing can make the phenomenon feel almost dreamlike, yet its cause is entirely physical. Charged particles move through tissue. Tissue responds. Perception translates the response into light. The chain is simple even when the experience feels strange. By the end of this section, the journey has moved from impacts on the moon to impacts on perception. Both involve fast particles crossing unshielded space. Both leave traces. One writes on rock, the other writes on vision. That prepares the next movement naturally, where the moon itself begins to show traces of another invisible influence through strange, bright patterns on the surface that may preserve the memory of vanished magnetism. Some of the moon's brightest markings are not craters, plains or rays. They are pale swirls that seem painted across darker ground without any obvious source. That is the early anchor of this section. These strange patterns matter because they suggest that the lunar surface can preserve the effects of invisible forces, not only visible impacts. The visual anchor is a curved, bright shape laid over a dark plane, soft-edged in some places and sharply defined in others. It does not resemble a splash from a fresh crater. It does not follow the neat geometry of a basin rim. It looks more like chalk dragged lightly across cooled basalt. That is the first payoff. The moon can display surface patterns whose meaning is not carved by collision alone, but by differences in how the ground has been exposed over immense time. A brief definition helps here. A magnetic anomaly is a local patch of stronger magnetism. After that, plain language can carry the rest. The moon has no strong global magnetic field like Earth's, yet some regions of its crust still retain small localized fields. These patches are weak on a planetary scale, but strong enough to matter at the surface over long spans. They appear to deflect part of the solar wind, which is the steady flow of charged particles streaming outward from the sun. That is the second payoff. Where the solar wind is partly diverted, the ground beneath can weather more slowly. Over millions of years, a visible brightness difference emerges. The darker surrounding terrain has been altered more thoroughly. The lighter swirl has been spared some of that change. A useful analogy is fabric left in sunlight with part of it covered by a thin screen. After long exposure, the unshielded cloth fades more. The protected patch keeps more of its original tone. The moon's swirls may work in much the same patient way. The physical detail is what makes this idea hold. Space weathering slowly darkens and changes the outermost lunar grains. Tiny impacts, solar wind particles, and long exposure alter the reflectance of the surface. If a local magnetic field bends some of that charged flow away, the rate of change can differ from one patch to the next. The result is not a raised ridge or a deep hollow. It's a tonal pattern laid across existing terrain. This is why swirls can look so odd. Their boundaries do not always match crater rims, fault lines, or lava edges. They ride over the topography instead of being the topography. A pale curve may cross a slope, then continue over flatter ground as though brightness itself had been brushed across the surface. The comparison here is to fingerprints left on a dusty mirror. The glass is flat and unchanged in shape, yet the pattern appears because some areas keep or lose dust differently. The moon's swirls are far older and more complex, but they carry that same feeling of a pattern written in exposure rather than in depth. A gentle limit of observation enters here. The eye can see that a swirl is brighter than nearby ground and that its shape does not behave like a standard crater feature. But brightness alone cannot prove exactly how the pattern formed. A local magnetic field cannot be seen directly in reflected light. Its presence must be inferred from measurements mapping and the way the bright marking aligns with the hidden field below. This is the limit. The surface offers a clue, not a full confession. Science must connect the visible pattern to the invisible structure beneath it. That work is careful because more than one process may have helped shape these regions. The moon often behaves this way. A feature that seems decorative from afar turns out to be a trace of deep history preserved not in obvious relief but in subtle contrast. The swirl invites the eye first, explanation follows more slowly. Another payoff comes from what these anomalies imply about the moon's past. If parts of the crust still carry magnetized signatures, then the moon must once have sustained stronger magnetisms than it does now, at least in some earlier phase of its history. The local fields become like surviving embers from a fire that no longer burns across the whole body. That image helps without turning the moon into something alive. A large furnace may cool, yet certain stones near its center can remain warm long after the room has gone cold. In a similar way, the moon's present quiet magnetism may preserve scattered records of an older, more active interior state. The visible swirls thus become double records. They show what the surface has been shielded from, and they hint at what the moon once possessed more broadly. This is the third payoff. A pale mark on dark ground can point both outward to the solar wind and inward to ancient lunar history. The scale shift here is especially calm. It begins with a thin, bright curve on the surface, perhaps no wider than a modest landscape by terrestrial standards. Then it expands to a regional magnetic field, hidden in crustal rock. Then farther still to the early moon, when interior conditions may have allowed stronger planetary magnetism. A local marking becomes a clue to a vanished global state. This movement from pattern to planet is one of the moon's quiet strengths as an object of study. Small differences on the surface often open into very large stories. The swirls are not among the biggest lunar features, yet they may preserve one of the most subtle records on the entire body. A basin tells of impact with force and depth. A swirl tells of shielding exposure and hidden structure. One story is written in broken rock, the other is written in uneven aging. The visual anchor returns one last time to the pale arc against dark basalt. It lies there without shadow or rim to explain itself fully. Its brightness feels almost detached from the landforms beneath it. That calm mismatch is part of what makes it memorable. The moon's surface usually teaches the eye to expect that visible differences come from shape. Here, visible difference comes from history written into exposure. A surface can be changed not only by what hits it but by what is deflected away from it. By the end of this section, the moon has revealed yet another layer of complexity. It is not only cratered and divided by crustal thickness, it also preserves hidden magnetic structure and patterns of light and dark. That prepares the next movement naturally. Once subtle surface markings begin to point toward invisible histories, attention can widen to the giant basins and deeper excavations that expose the moon's interior more directly through immense ancient impacts. The largest clues on the moon are not lines or swirls, they are holes of astonishing scale. That is the early anchor of this section. Giant impact basins matter because they do more than scar the surface. They excavate depth-rearranged crust and preserve the mechanics of violence that shape not only the moon, but much of the early solar system. The visual anchor is a vast ringed depression seen from above at an angle, with one curved mountain wall beyond another, and a broad floor lying between them. The structure resembles ripples frozen in stone after a single impossible strike. That is the first payoff. A giant basin is not just a crater made larger. It is a record of the crust flexing, collapsing, rebounding, and settling after an impact powerful enough to alter a region hundreds or even thousands of miles wide. A brief definition helps here. An impact basin is a very large crater with ringed structure. After that, plain language is enough. When a smaller object strikes, it may leave a simple bowl and a raised rim. When a much larger object strikes at immense speed, the ground does more than open. It behaves almost like a surface under sudden compression and release. The crust bends downward, materials thrown out, and inner regions rebound. Rings can form in stages as the ground adjusts to forces far beyond ordinary intuition. This is the second payoff. A basin preserves motion that is long finished. The shape visible now is the still result of a brief catastrophe that once moved stone as though it had lost some of its stiffness. A useful analogy is a heavy drop falling into thick batter rather than into water. The surface caves, rises and settles into concentric forms, but the final pattern remains fixed once motion ends. The moon's crust is not batter, of course, but the image helps the mind accept that hard rock can transiently behave in ways daily experience does not suggest. Physical detail gives the basin its authority. Outer rings may rise as mountain belts. Inner rings may arc closer to the centre. The floor can later be partly flooded by lava if the crust allows molten material to rise. Slopes may show terracing where material once slumped inward. A basin therefore contains layers of history within one feature. First the impact, then structural adjustment, then possible later volcanism, then billions of years of smaller impacts softening or interrupting what came before. A ringed basin is a landscape and a timeline at once. This is the third payoff. Looking at one large basin is like reading several chapters of lunar history compressed into a single form. A bright young crater may tell of one event. A giant basin tells of event aftermath and survival altogether. The eye can trace arcs in the terrain. The mind can then infer sequences that no witness ever saw. A larger scale shift now begins. One basin can span the distance between major cities on Earth. Another can stretch across a huge fraction of the moon itself. This is where the moon moves beyond familiar landscape and becomes planetary architecture. A depression so large that its curvature is hard to grasp in one view no longer feels like a feature placed on the moon. It feels like part of how the moon is shaped. Some of the most immense basins may even have punched through much of the crust and disturbed material from far below. That matters because the deeper layers of world are usually hidden. A giant impact can force them closer to the surface. The analogy here is a torn page in a bound book that exposes the paper beneath several upper sheets. The tear is damage, but it is also access. The moon's great basins are like that. They are wounds that reveal deeper composition through the material they disturb and expose. A gentle limit of observation belongs here. Even a huge basin seen clearly from above does not announce its full story by the shape alone. Rings show that the crust responded in complex ways, but exact depth of excavation, mantle involvement, and thermal consequences must be reconstructed indirectly. Samples, gravity data, mineral signatures, and structural modelling all help fill the gap. This is the limit. The eye can recognise immensity and pattern. It cannot directly measure how far downward the original shock reached. Planetary surfaces often offer this kind of partial honesty. They show the result magnificently, while the exact pathway to that result must be assembled with care. The moon's large basins are especially powerful because they sit at that boundary between obvious form and hidden process. Their size is undeniable. Their deepest implications remain partly inferential. Another payoff arrives through comparison between younger and older basins. A younger structure may preserve sharper rings and cleaner relief. An older one may appear softened, battered, and interrupted by later impacts. That contrast creates a slow visual time series. It is like comparing two ancient coins, one with edges still crisp, and another worn smooth by long handling. Both were struck from force. One has simply endured more overprinting from time. On the moon, time is not measured mainly by rainfall rivers or plant cover. It is measured by bombardment, dust reworking, and gradual optical aging. A basin that has survived in recognizable form for immense spans becomes a marker of both durability and change. Its rings remain, but they are not untouched. That combination is what gives the lunar surface its unusual calm. Catastrophe happened early and decisively. After that, alteration continued slowly enough for the record to stay legible. The visual anchor can widen once more to the largest basins of all, where the floor seems to sink into another register of scale, and the surrounding rings feel less like mountains than like the edges of a broken planetary shell. At that point, the section reveals its largest unlock. The moon is not simply cratered, it is deeply excavated by a few events so immense that they help explain the early environment of the inner solar system itself. To study those basins is to study a time when impacts were not occasional interruptions. They were among the dominant forces shaping young worlds. By the end of this section, the surface has widened from local scars to planetary wounds. The moon now appears not only as a place of ongoing small impacts, but as a body whose deepest visible structure was set by ancient giant collisions. That prepares the next movement naturally. Once the giant basins have opened, the question of depth and excavation Attention can turn to what future exploration seeks within that harsh terrain, especially where shadow cold and hidden reserves may alter the long story of return. The most valuable lunar resource may lie where sunlight does not reach. That is the early anchor of this section. The moon is often imagined as uniformly dry, and in broad terms that is true. Yet deep shadow near the poles changes the thermal story so completely that traces of water can survive there for the immense spans. The visual anchor is a crater near the pole with a floor in permanent darkness and a rim brushed by a low cold light. The interior is not merely dim, it is a place where the sun never climbs high enough to touch the deepest ground. That is the first payoff. A small change in geometry can create one of the most important environmental differences on the moon. The pole is not only a location, it is a thermal trap. A short definition helps here. A permanently shadowed region never receives direct sunlight. After that, plain language can continue. Near the lunar poles, the sun stays low along the horizon because of the moon's orientation. Some crater floors and steep-sided hollows remain in shadow all the time. Without direct sunlight, temperatures there can stay extraordinarily low. Cold this persistent matters because water delivered by impacts or produced through subtle surface processes is less likely to escape back into space once it settles into such a trap. This is the second payoff. Water on the moon does not need rivers, rain, or lakes to matter. Even ice mixed into shadowed soil can transform what long stays near the surface might eventually require. A useful analogy is frost surviving all day in the deepest corner of a stone courtyard long after the brighter ground has warmed. The courtyard is not a glacier, yet one protected patch preserves what everywhere else would quickly disappear. The physical detail is worth holding carefully. Lunar water, where it exists at the poles, may not appear as smooth, clear sheets. It can be mixed with dust trapped in grains or buried in cold regolith. Some deposits may be patchy rather than continuous. Some may be richer in one shadowed hollow than in the next. This means the search is not only about finding cold, it is about finding the right combination of cold delivery, history, grain structure, and retention. The moon's surface adds another complication. Dust is sharp, dry, and electrically active in subtle ways. It can cling shift and cover what lies beneath. This is the third payoff. A cold trap is not a simple container waiting to be opened. It is a difficult environment where valuable material may be present in forms that are uneven, hidden, and mixed with harsh terrain. The promise is real, but the landscape keeps it under demanding conditions. Another payoff appears when water is translated from chemistry into purpose. Water matters because it is not only for drinking. It can support life systems, help regulate habitation, and be separated into hydrogen and oxygen. Oxygen can support breathing. Hydrogen and oxygen together can support fuel production. This turns a cold deposit into something larger than a local curiosity. The presence of extractable water changes logistics. It changes what must be carried in from Earth and what might eventually be produced closer to where it is needed. The analogy here is a well in an otherwise dry settlement. The settlement may still require shelter tools and planning, but once water is present, many other possibilities rearrange themselves around it. The moon's poles may play a similar role. A shadowed crater is still harsh, but nearby access paid to ice can alter the long arithmetic of staying. A gentle limit of observation belongs here too. Remote sensing can indicate the likelihood of ice or hydroxyl-bearing material. Temperature mapping can show where cold traps persist. Reflectance patterns can suggest unusual surface properties. Yet from orbit inference remains stronger than certainty in many cases. This is the limit. Darkness hides as much as it preserves. A permanently shadowed floor is hard to inspect directly because the very condition that protects volatile material also blocks ordinary viewing. Light-based observation weakens where sunlight never falls. Instruments can look indirectly, but interpretation remains careful and partial. This matters because the poles attract imagination very easily. A hidden reserve can become larger in thought than in reality. The moon asks for patience here. It offers hints through temperature shadow and spectral signatures. It withholds easy confirmation. The scale shift in this section is especially calm. It begins with a narrow strip of shadow beside a crater wall. Then it widens to a regional pattern of polar hollows, ridges and basins arranged around low-angle sunlight. Then it widens again to the long future of exploration, where choice of landing zone route and habitat may depend on these cold pockets. A thin seam of ice in a dark place can influence a whole architecture of return. That is one of the moon's quiet lessons. Small concentrations in the right environment matter more than abundance in the wrong one. A little water preserved where it can be reached may matter more than a larger trace scattered through sunlit dust. Terrain turns chemistry into strategy. The visual anchor returns once more to the polar crater. Its rim glows faintly. Its floor remains black, not because nothing is there, but because the angle of the sun keeps the interior beyond direct sight. The contrast between illuminated edge and hidden interior is the heart of the section. The moon shows possibility through absence. A place too dark to examine easily may also be the place that holds what future presence needs most. That inversion gives the polar landscape its unusual pull. The richest promise may lie where vision works least well. By the end of this section, the moon has shifted again. It is no longer only a scarred archive or a hazard-rich surface. It becomes a place where shadow itself may preserve the materials needed for longer return. That prepares the next movement naturally. Once the poles and their cold traps enter the story, the journey can rise from resource and terrain into a rarer visual event where the sun, moon, and surrounding darkness align to create the long eclipse that reframes the entire flyby in light. The most extraordinary light of the journey appears when the sun is hidden almost completely. That is the early anchor of this section. An eclipse near the moon does not behave like an eclipse seen from Earth because the geometry, motion, and surrounding darkness are all different. The visual anchor is a black lunar disk covering the sun, while a pale crown of light extends around it in fine, uneven strands. The scene is not bright in the ordinary sense. It is precise. The moon becomes a dark circle without surface detail, while the corona stands out as a delicate structure usually drowned by the sun's glare. This is the first payoff. Cover the brightest part of the sun and a hidden outer atmosphere becomes visible. The eclipse does not create the corona. It reveals what was already there. A short definition helps here. The corona is the sun's outermost atmosphere. After that, plain language is enough. Under ordinary conditions, the sun's visible surface is so intense that the faint outer layers disappear in its brightness. When the moon blocks that overwhelming center, the fine structure around it can finally be seen. Long streamers extend outward. Brightness is uneven from one side to another. Some regions look smooth and soft, while others stretch into narrow, luminous threads. The physical detail matters because the corona is not a simple ring. It has text, direction, and internal structure shaped by the sun's magnetic field. This is the second payoff. The eclipse turns a blinding source into a readable one. What had seemed like a solid, bright disk becomes a layered system with a hidden outer form. The geometry of the event explains why the experience feels so unusual. On Earth, totality usually lasts only a few minutes because the shadow moves quickly across the ground. Near the moon, the alignment can hold far longer, depending on the path and relative motion. That change transforms the event from a brief interruption into an extended condition. The analogy here is simple and calm. A passing cloud may cover the sun for a moment when seen from a field, but if the observer moves with the cloud at nearly the same pace, the shade can linger. The eclipse near the moon works by a similarly patient relationship of motion. The shadowed condition is sustained rather than rushed. This is the third payoff. Time changes the character of the event. A short glimpse becomes a prolonged state, and the eye can settle into details that would otherwise vanish before they are fully absorbed. Another visual layer enters through the edge of the moon itself. The lunar limb is not a perfect smooth line. Mountains crater walls and irregular rises create a broken boundary where sunlight meets the disk. At certain points, fine bright points may persist along the edge, before disappearing and the silhouette feels carved rather than mathematically clean. This detail matters because it reminds the eye that the black circle in front of the sun is not abstract. It is terrain. A world stands between observer and star. The comparison that fits best is lace. Held before a lamp. Except here, the lace is not delicate cloth, but a distant rocky horizon, with minute unevenness made visible only because the background is so bright. The result is a scene of both sharpness and softness. The moon's edge is hard. The corona around it is diffuse and flowing. One body blocks, the other body extends. A gentle limit of observation belongs here as well. Even in a long eclipse, the eye cannot hold the whole solar structure at once. Bright inner regions can overwhelm fainter outer ones. Subtle extensions may be visible for a moment and then disappear as attention shifts. The corona is easier to see during totality, but not fully easy to understand by sight alone. This is the limit. The eclipse offers visibility, not total comprehension. Structure becomes apparent, yet the forces organising that structure remain mostly inferred from the deeper solar study. This matters because the scene can feel so complete that it seems self-explanatory. In truth, it is only a rare opening. The hidden outer sun becomes visible, but its full behaviour still exceeds immediate intuition. The eye receives beauty first. Explanation follows later and only in part. The scale shift here is especially wide and quiet. It begins with a fine thread of light beside the black disk. Then it expands to the corona extending outward for enormous distances. Then farther still to the star itself, whose visible face has been hidden, while its outer atmosphere quietly fills the frame. A small blocked circle in the foreground becomes the key to reading the edge of a star. That reversal gives the eclipse its depth. Something comparatively small reveals something vastly larger by standing in front of it at exactly the right angle. The moon acts like a dark coin held before a lantern, except both coin and lantern are worlds apart in size and distance. This is why eclipses remain so powerful. They compress alignment, scale, and revelation into one stable image. There is one more payoff in the darkness around the eclipse. When the sun's surface is covered, other points of light can step forward. Nearby planets may become easier to notice. Faint background glow changes character. Even the night side of the moon may begin to show detail under Earth, shine the soft reflected light from Earth. This means the eclipse is not only about the sun disappearing, it is also about the rest of the scene becoming newly legible. Hidden relations emerge when the brightest object is reduced. The principle is simple and broad. Lower one dominating glare and subtler structures can finally be seen. The moon, the corona, and the surrounding darkness all benefit from that temporary balance. By the end of this section, the flyby has reached its most luminous stillness. The eclipse reveals that concealment can be a form of disclosure, and that shadow can make structure visible. That prepares the next movement naturally. Once the journey has passed through this long alignment of light and darkness, the story can widen again to continuity across generations, where the path around the moon becomes part of a longer human arc rather than a single isolated event. A path around the moon is never only a path in space, it is also a path through continuity. That is the early anchor of this section. One mission follows another, not by repeating the same view exactly, but by crossing some of the same geometry with new bodies, new questions, and a changed sense of what the journey means. The visual anchor is a curved trajectory bending behind the moon and then opening again toward Earth. Nothing about the line is visible in space itself, yet the mind can trace it through changing position, changing light, and returning sight. The curve resembles a sling pulled back and released, except the release is not sudden. It is a long controlled bending of motion around gravity. That is the first payoff. A lunar flyby is not merely travel past an object. It is a shaped encounter in which the moon redirects the journey and becomes part of the route home. A short definition helps here. A free return path loops around the moon and heads back. After that, plain language is enough. The important point is simple. The moon's gravity can bend a spacecraft's motion so that the outbound journey naturally becomes a return arc. This gives the route a quiet elegance. The same body that draws the traveller outward also helps guide the way back. The second payoff follows from that structure. Continuity in lunar exploration is not only emotional or historical, it is physical. Later journeys can inherit the same graceful mechanics that earlier journeys used. The analogy here is a mountain pass used across generations. Different travellers bring different aims and different burdens, but the pass remains because the terrain still channels motion the same way. The moon offers that kind of pass in space. Physics keeps it open even as history changes those who cross it. The physical detail that gives the section weight is the balance between sameness and difference. The same moon still blocks radio on the far side. The same gravity still bends motion around it. The same horizon still lifts Earth back into view after blackout. Yet each return to that route carries new context. Light falls at a different angle. The spacecraft sits at a different altitude. The questions asked of the surface have changed. Even the meaning of the crew has changed because what once belonged to a narrow era can later become more representative of a wider world. This is the third payoff. Repetition in exploration is never exact repetition. It is structure renewed under altered human circumstances. The moon stays old, the journey changes around it. A gentle limit of observation belongs here too. Continuity can tempt the mind into believing that later missions simply relive earlier ones. They do not. Historical memory compresses difference. It remembers common milestones and shared images, then smooths over the altered details of technology purpose and perspective. This is the limit. Similar trajectories can conceal very different contexts. The same far-side blackout can feel different when the public expectation mission goals and the meaning of representation have shifted. The same Earthrise can strike differently depending on how long it has been since anyone last saw it from that distance. Memory loves echo. History contains variation. The moon holds still enough to make the echoes obvious, but not enough to erase the changes brought by time. Another payoff appears through the idea of records. Distance records in space have a strange character because they feel both precise and temporary. One mission becomes the farther, then another surpasses it. The number matters, but the larger meaning lies elsewhere. A record in exploration is often less a final triumph than a marker placed on a road that is meant to continue. The useful analogy is a cairn on a high trail. It tells later travellers where someone passed before. It is not built so that no one else will go farther. It is built so that the route remains legible. This is why continuity matters more than the single moment of surpassing. The moon does not care which passage was first or farthest. The value lies in the widening of the route itself. A path that can be taken again begins to shift from legend toward practice. The scale shift in this section is especially calm. It begins with one trajectory arcing around the moon, then it widens to the span between generations of lunar flight. Then it widens again to the longer human pattern of testing a route, losing contact with it for decades, and then returning with altered aims. Time here is measured in minutes during blackout days during the mission, decades between eras, and longer still in the future arc that may extend toward more sustained presence. One curved path holds all of those scales together. A quiet loop around the moon becomes a thread connecting different periods of ambition. The moon serves as hinge rather than endpoint. That is the larger unlock of the section. Exploration matures when a destination begins to function as a turning point toward what follows. The visual anchor returns one last time to the unseen line of travel. Outbound motion, hidden passage, reappearance, return. The beauty of the route lies in its restraint. No dramatic detour is required. A clean bend in space is enough. That simplicity explains why it can carry so much symbolic force. A loop around the moon can join past and future without needing to say so aloud. The geometry already contains the metaphor. One world is approached, circled and left behind, yet not as a rejection. The curve uses the encounter to go on. By the end of this section, the journey has widened beyond a single flyby into a longer continuity of routes, records and return. The moon now stands not only as landscape hazard, archive and a mirror, but also as a hinge in a larger arc of exploration. That prepares the final movement naturally. Once the route has been understood as part of an ongoing passage, the story can settle into its closing view where shrinking distance, growing perspective and the quiet contrast between Earth's fragility and the moon's endurance come to rest together. The final lesson of the moon is not about conquest or distance, it is about proportion. That is the early anchor of this closing section. By the end of the journey, the most durable impression is not simply how far the path has gone, but how clearly the view has sorted what is enduring from what is fragile. The visual anchor is quiet and balanced. The moon recedes behind as a grey, scarred sphere. Earth grows brighter ahead as a small blue world wrapped in a thin, luminous edge. One body appears ancient and untroubled by change in any human sense. The other appears active, delicate, and full of motion contained inside a narrow film. This is the first payoff. The moon teaches scale by contrast. It shows permanence through stone and vulnerability through air, water, and light. The physical detail that carries the section is the atmosphere. From Earth's surface, air feels endless because it surrounds everything and rarely presents its own boundary. From far away, that boundary becomes visible as a thin line. Oceans, cloud systems, and land patterns remain inside it like colours beneath clear glass. The moon offers almost none of this softness. Its surface is hard-edged. Crater rims persist. Shadows stay dark. Colour is muted and dry. The second payoff settles gently from that comparison. Life depends on a layer that is visually slight. The most necessary part of Earth is not what dominates the frame. It is the narrow envelope around the frame. A useful analogy is varnish on old wood. It may be only a thin coating, but it determines whether the grain survives weather or begins to fail. Earth's atmosphere is not a coating in the mechanical sense, yet the comparison helps. Something thin can still be decisive. Another payoff follows from time itself. The Moon has endured impacts for billions of years and keeps their records openly visible. Earth experiences impacts too, but its surface is rewritten by tectonics, water, wind, and life. One world preserves, the other renews. Neither condition is superior in itself. One gives memory and stone, and the other gives change and habitation. This is the third payoff. The difference between the two worlds is not only one of appearance, it is one of process. The Moon seems calm because it changes slowly in the visible sense. Earth seems familiar because its constant change surrounds daily life and so often goes unnoticed. Distance reverses that habit. From far away, Earth's motion becomes visible through cloud spirals and shifting brightness. The Moon's stillness becomes visible through its fixed scars and dry tones. Each world explains the other by standing beside it. A gentle limit of intuition belongs in this final section as well. The mind often assumes that what feels stable must be safer and what changes must be more fragile. From one angle that seems true, the Moon preserves itself visibly because so little softens its surface. Yet that same exposed stillness is part of what makes it harsh. Earth's shifting weather, oceans, and atmosphere may seem as less stable in a visual sense, but they are exactly what make it habitable. This is the limit. Human intuition can mistake visible permanence for generosity and visible change for weakness. The larger view corrects that error. A world may endure without offering comfort. Another may remain livable precisely because it never stops circulating energy, water, and air. The Moon and Earth embody that contrast in the clearest possible way. The scale shift in the closing movement is broad but calm. It begins with one returning spacecraft and one shrinking moon. Then it widens to the whole history of human absence and return. Then farther still to the age of the lunar surface and the deep continuity of planetary change. Finally it narrows again to one thin atmosphere around one blue world. The largest truths arrive by narrowing, not only by expanding. A planet can be understood through a line of light. A moon can be understood through a field of craters. A long mission can resolve into a few enduring images. A bright Earth above a grey rim. A black lunar disk holding the corona. A fresh pale crater against older ground. A hidden polar shadow preserving cold. A streak of light in darkness inside vision itself. The story settles by allowing these images to remain distinct rather than forcing them into one final grand statement. That restraint is part of the restfulness of the ending. Another soft payoff appears in the idea of return. Returning from the Moon does not diminish what has been seen there. It clarifies it. Distance is useful partly because it allows the ordinary to become visible again. A coastline becomes striking after long time inland. A familiar voice becomes weighty after silence. In the same way, Earth becomes newly legible after the Moon has shown what a world without weather, without thick air, and without easy softness looks like. The comparison here is a room entered after standing in winter cold. The room has not changed, but its warmth becomes vivid because of where the body has been. The Moon creates that kind of contrast for Earth on a planetary scale. It does not make Earth important. It reveals the importance that was already there and too near to notice fully. The visual anchor can close with the simplest arrangement of all. Behind the Moon continues in its patient orbit, one face long, known, one face long, hidden, both marked by impacts and time. Ahead Earth brightens, carrying cloud ocean and a thin protective glow. Between them lies the path that has just been traced, a path of blackout observation, impact flashes, polar shadow, strange surface swirls, giant basins and eclipse light. None of those scenes needs to be sharpened further now. They have already done their work. The Moon has served as archive hazard mirror and hinge. Earth has returned as the small, radiant centre of everything that can be called home. The journey resolves there, not in suspense, not in triumph, in proportion. The Moon remains what it is, a dry, patient record of deep time. Earth remains what it is, a bright and fragile world whose livability depends on layers so thin they can be held in a line of light. Seen together, they quiet the mind more than they excite it. One shows endurance without shelter. The other shows shelter within change. Between them, the long curve of return comes to rest.